So hello guys, now we are going to discuss about the magnifying power of the compound microscope when final image is formed at infinity. So let's say AB is the object and the rays are coming from the object like this. After refraction, this ray will pass through the focus. This is the ray which is passing through the focus. And now the second ray will pass through the optical center. The second ray should pass through the optical center and it will go without any deviation. It will go like this, A dash, B dash. Now A dash should be set like A dash should be somehow you have to manage A dash that it should lie on the focus of the eye lens. Somehow you have to make the adjustment in such a way that A dash should be the focus point of the eye lens. So this should be focus of eye lens like FE dash, and let's say this is FE. In the same way, we have to also mention the focus of objective lens. Now, on further refraction, these rays will go like this. Keep in mind, these rays, further refraction. Let me first erase this thing. I have to erase this extra part. Okay. Now, what will happen? These rays will converge because this is a converging lens. These both rays will converge toward the principal axis, and these automatically become parallel because the object is placed at focus. And if you draw backwards, what you will get? You'll get this kind of parallel rays. And these rays we assume, and these rays will meet at infinity. So these rays are going to infinity. The final image is formed at infinity. In this situation, magnification of the eye lens is given by D upon Fe. And in the same way, the magnification of objective lens is given by V by U. And you have to keep in mind, like this distance is minus UO. So take it minus UO. In the same way, this distance is plus ka VO. You have to take plus VO. Also, this distance A dash B dash works as the object for the eyepiece. So this should be the distance of object from the eye lens. And the distance of the image made by the eye lens is at infinity. So you don't need to take that thing because it's infinity. We already know that. Now, the magnifying power of the objective lens is given by plus VO divided by minus UO. And the net magnification you can write like this. M is equals to MO into ME. The net magnification is minus VO by UO into D upon Fe. Okay. Keep in mind, the eyepiece is working as a simple microscope. So this is the formula for the simple microscope when the final image is formed at infinity. And this works as the simple lens. This is the formula for a normal lens. Like this is a normal lens which we have studied in 10th class. This normal lens. And the second eyepiece lens works as the special lens, which is the case of simple microscope when the image is formed at infinity. Keep these two things in mind. And that's how we got the MO and ME. And after putting these values in this expression, like this is the expression of final magnifying power of the compound microscope, we got this expression. Okay. Now sometime they ask what is the what is the length of the compound microscope. So length means the distance between the objective lens and eye lens. This is the length of the compound microscope. So take it L. So that should be VO plus UE, and you have to take mod of UE because the length is always positive. And keep in mind, this is also the focal length of the eyepiece. So you can take UE also. So you get the answer VO plus FE. Keep in mind. And you have to take mod both. You can take the both in mod because length is always positive. So keep in mind, this distance is also the focal length of the eyepiece, and this distance is also the distance of the object from the eyepiece. Okay, so one thing I want to tell you, keep this concept in mind. Like if we have multiple lenses, like we have let's say this is the first lens, and we have second lens, and then we have third lens. You can take multiple lenses. So let's say this is the object for the first lens, and we have to take the axis like this. This is the image of the first lens. So let's say this is AB. Take it like simple, like this is object, take it O. Now this is I1, this is the first image made by the first lens, but this is the object for the second lens. Keep in mind. Now that let's say this is the second image made by the second lens, but this I2 is the object for the third lens. Keep in mind, an image for the second lens. So very important. The object made by the second lens, the image made by the second lens works as the object for the third lens. In the same manner you can carry on. Okay, now let's say this is, okay, just hold on. This is I3. So this is the image made by the third lens. Got it? So you have to keep in mind, image of the one lens could be the object for the second lens. Keep in mind. So that concept we has applied here in the previous slide. Over there we have applied that concept. Okay, so that is the derivation for the relaxed eye case.